Hello student, this is a question 1.68 of the book I.E.Erodov, and the question is based on the dynamics. And first of all, we understand the questions, then we will start a solution of these questions. So question is given that at the moment t equal to 0, the force F equal to 80 is applied to a small body of mass m resting on a smooth horizontal plane where a is a constant. The permanent direction of this force form an angle alpha with the horizontal. Find the velocity of the body at the moment of its breaking of the plane. And second question is the distance traversed by the body up to this distance. So when the body is leave of the surface, then what will be the distance traveled and the velocity at this moment? So first of all, we will draw the ability of the given question. So this is a this block, okay, and this is mass m and force acting in the directions in this direction force F and making an angle alpha. So component in the direction of the motion is F cos alpha, and in the perpendicular directions will be F sine alpha. Okay, and in the downward direction the mg force, and due to the horizontal surface a direction force is N. Okay, and placed on the smooth horizontal surface there is the no friction force. Friction force is absent. Okay, so there is no motion in the vertical directions. So we will balance the forces in the vertical directions comes from N plus F sine alpha equal to the mg. And body will accelerate due to the external force in the horizontal directions. Body will accelerate with the acceleration A. So this is the first equation. Second equation is dynamic equation, and first equation is the equilibrium equation. So dynamic equations F net, the direction of the motion equal to mass to acceleration. Okay, this is the equation number 2. So when the body leave the horizontal surface, in this case, the n will be big, n becomes 0. So when body leave the surface, when body leaves the surface, there will no contact, there will no contact, normal reaction force. So n becomes 0. So equation 1 become here, equation 1 become F sine alpha equal to the mg. Okay, so force become here mg mg sine alpha mg upon sine alpha. So the velocity of the body at moment of its breaking off. So the moment, what will the time when it break? So here f value, f is not a constant, f is a variable, is the 80. 80 equal to the mg divided by the sine alpha. So value of the time, so time t equal to the t equal to t naught here, breaking time. So mg upon the a sine alpha. This is the time at which the body leaves the horizontal surface. At this instant, what will the velocity? So using equation 2. Here the 2a, one is the a constant and another here we are using the a for the purpose of the acceleration. So here I am putting another symbol that is the w. Okay. Now use equation number 2. Equation 2. In the equation 2, F net, F cos alpha equal to mass to acceleration, and this can written dv upon the dt. And force is variable at cos alpha equal to the m dv upon dt. Further solving, m dv equal to the some adjustment here made, a t cos alpha and dt divided by the m. Okay. Now integrating both sides. In the question is given that body start at the moment t equal to 0, the force F equal to the force it is applied. That means initial velocity is 0. At t equal to 0, no force, no velocity. Okay. So at t equal to 0, the velocity is 0. At times 10t, velocity becomes v. So this time will be the t naught when the body leaves the surface, the breaking of the plane. Okay. So this is the v equal to the a cos alpha divided by the m and t dt. This becomes the t square by the 2. So 0 to t naught. Now velocity becomes a cos alpha divided by the m and the t naught squared by the 2. Okay, the v equal to the a cos alpha by 2m, and the value of t naught is mg upon the a sin alpha, mg upon the a sin alpha square. Okay, so m g square, 1m is cancelled out here, and cos alpha remaining in the numerator, and in the denominator, 1 is the a, and there is the sin square alpha, and 2. So in the numerator comes out to be mg square, mg square cos alpha and 2a sin square alpha. This is the velocity when the body breaking of the plane. When body breaking of the plane, the velocity is. Second question. This is the question number one answer. Second question answer. The distance traveled by the body up to this distance, this moment. So how can we calculate the distance? Here, the velocity is constant. So here this velocity become constant. This is the particular velocity at the moment when the braking takes place from the plane. Now distance calculation. Distance. So how can we calculate the distance? Yeah. This is the time dependent, or again we using the equation number 2. So again using equation 2, equation 2. So at because here the f cos alpha, f cos alpha equal to mass into acceleration. This becomes the v dv upon the ds. This is the distance. Okay, but here the variables t and s is different thing. So how is possible to calculate the velocity? For this purpose, first of all, we will find the velocity with variable time, with variable time, then with variable time. Okay, with variable time. So again using equation 2, that the f cos alpha equal to the mass to the accelerations. Force is 80. This is the cos alpha equal to mass and dv upon the dt. So dv comes out to be m, sorry, a cos alpha t dt divided by the n, integrating both sides. Initial velocity 0 at the moment when the time is t, velocity is v, and initial at velocity 0, this time is t, time is 0. Okay, time will be 0. Now solving this question, so here is the v and is the a cos alpha divided by the n and the t dt integration t square by the 2 finally. Okay, that's it. Now again we place v as the ds by dt. Okay, so a cos alpha by m t square by the 2. Now ds equal to the a cos alpha divided by 2m, and this is the t square dt. Integrating both sides. Okay, so 0 to distance s and 0 to time t naught. S equal to the a cos alpha divided by the 2m, and this is the t cube by 3, 0 to time t naught. So S equal to the a cos alpha upon the 6m, and this is the t naught cube. A cos alpha upon the 6m. So t naught value, again substituting the value of t naught, and this is mg upon the f sin alpha. Mg upon the s sin alpha. S equal to the m square g cube divided by the 6, and in the numerator is m cube, and in the denominator is m. So in the numerator m square remaining, and another is cos alpha. In the denominator 6, and a square, and this is the sine cube alpha. This is the distance traveled. Thank you.